Kevin Perrott and OpenCures. Kevin is the founder of OpenCures, a cancer survivor, and has focused the last 20-ish years of his life on longevity. We dive into the world of citizen science and the power of individuals to drive the development of preventative and personalized medicine. OpenCures Biobank and Kevin's plans to affect longevity. If you like this type of unedited, long-form content, please like and subscribe. Every bit helps. We are working to put out 2 to 3 episodes every week and have cool things planned for when we reach 10,000 new subscribers. Additionally, in this episode, I'm still recovering from the flu, so I cough a little bit. Just want to give you guys a heads up. Chapters and show notes below. Let's stay curious and learn about Kevin, OpenCures, and the mystery that is longevity in this episode of the Learn With Lowell show. So for people who are unfamiliar with you, what is basically your main thesis on aging, and then how does it relate to OpenCures and the work that you're doing?
Aging, for me, has evolved over the past couple of decades that I've been studying it. And for me, at first, it was this damage repair. And then I became to realize that everything is sort of informational, and information doesn't necessarily have substance. There's dynamics and algorithms and relationships, which rather than individual entities. So I think there's 2 components to aging now. I think there's a regulatory sort of informational, almost a non-material emergent type of a deterioration of the integrity of an information system. And that deterioration is often caused by damage, not just often, probably caused by damage to the individual components of the system. But then there seems to be sort of like, how do those, it's the maintenance of those systems. It may not be inevitable that we do not have self-repair. How far can we push self-repair before we just give up and say, okay, now we have to do, exogenous sort of types of treatments to address different types of damage. I think they have to go hand in hand, basically.
And then for OpenCures, like how is that impacting? How does that lens affect how you make decisions and stuff?
So aging itself obviously is a problem. I basically figured I'm 59. I've been doing this for a couple of decades. I thought I started out when aging was not a financial incentive. In fact, people thought you were crazy if you talked about doing anything about aging at all. So I was never involved for the sort of financial incentives of it. And it's changed, for me, the impact would be the glass ceiling of aging, trying to do something about it and, improve the world because of it. And there is really no way of getting there if you don't measure things prior to the onset of the degenerative conditions that we now call aging. But for me, there's now pathological changes occurring at the biochemical level. You don't see them, you don't feel them, but they're occurring. And those are the fundamental aberrations and imbalances in biochemistry in the system that lead to the eventual, sort of like rust, long before you see bubbles in the paint, there's rust going on in the metal, sometimes for years before you start to see that. So I believe I backed up and I look at aging now as almost a biochemical problem. And so I think we need to be able to predict what these biochemical aberrations result in, but you can't predict if you don't measure. So my view has gone from finding actual interventions, because we've been looking at rapamycin for 13 years. It's pretty ridiculous, actually, that we haven't gotten better interventions on the go since we've actually started this journey. And so I'm going, how can we warp speed? How can we warp speed the development of interventions? And so instead of focusing on individual interventions, which are by and large minor improvements to what Mother Nature can do, so how do we get to the real ability to do something about aging and measure the effectiveness of interventions? So OpenCures is about gathering the necessary data from humans that can be used to drive a prediction engine to tell them when their health is not good, not bad. I mean, it's what a lot of people are doing with biological scores and all sorts of other things. We have somebody who has just arrived. Hello. You'll have to edit that out. Thank you. Oh, lovely. Yeah. Okay, so I'll start with the biological scores. So
I think this is the multi-omic data gathering that you've been doing, right?
It's multi-omic data. Everything is health data. Your social network data dictates your mental health. Your financial data sort of probably also dictates your mental health. There's a whole bunch of ways of gauging how healthy you are, and it's not just physically healthy, because everything is intertwined. And just looking at your biochemical levels or various other biomarkers is not really enough. That's a snapshot, but it doesn't tell you how healthy is the dynamic system. So I often will say, okay, everybody goes to genetics, as genes are the be all and end all for a lot of people, computationally especially. But when you want to know how well your car is operating, you don't go look at its blueprint.
Mm-hmm.
No. I mean, how healthy are you today? Well, you're not going to go look at your genome. You shouldn't. Genome's a pretty poor predictor as to how healthy you are, unless you have a pretty major flaw in your blueprint. So that's kind of where everybody's been focusing on, is the real sort of easy stuff, often just to make money. What is the easy stuff that I can use to make cash? Not what is the most important stuff that I can use to minimize the time to the development of interventions. So that's my key driver, is minimizing time. Everything else is a slave to that particular goal, including maximizing profit. So, of course, it's always good to make money and sustain yourself, but if you're dead, you can't spend it. If you're sick, you're probably still not going to be able to spend it. So it's remarkable to me that everybody is as insane as they are about acquiring power and position and reputation and all of these sort of monkey brain goals, instead of saying, okay, what's the real problem here, is that we all are running out of time, and how do we reward those individuals and entities which are working on ways of maximizing time and minimizing the time to the development of those methods. So right now there isn't a system that does that, and the reason why is because the actual customers for these interventions are not responsible for helping create them or fund them or research them. So the customer is never really served here in terms of the medical environment. I'm a cancer survivor. It was actually the best thing that ever happened to me, because it put me on this path. Because while I was laying in the hospital bed wondering, why is it that science and the best that medicine have to offer is like poison and surgery? This is the limit of the benefit of what modern technology is capable of producing. And this was quite a while ago, so things have moved on. We got CAR-T and a few things, but still. And the iterative discovery to application cycle is slow. I mean, and halting, and it's just impossible. So for me, after 20 years of trying to minimize time to the development of interventions, I realized that the whole system is backwards to that. It's not responsive to the needs of the customer, the patients. I come from a family background where we have a retail business. We sell power sports, motorcycles, and snowmobiles, and we've been in business for over 50 years. And I managed a company for a couple of decades. And it was, if customers are not served, you go broke, which is why we survived for 50 years while we've buried 30 or 40 competitors, and why we're still very, very successful is because we actually serve the needs of the customer. If the medical system and the research system were the current health technology development paradigm was a business, and its survival depended on customer satisfaction, it would be dead in the water in a half an hour or an hour. It would not take long for people to figure out that everything is actually just using the misery and the suffering of individuals as a they say, they give it lip service. Yeah, we're trying to help the sick and the dying. But actually, no, we're trying to help the sick and the dying, but we're going to get our cut first, basically, or we're going to. They're padding their CVs and they're padding their pocketbooks with the misery and suffering of other people. They don't like to think of themselves like that. There's a lot of good people within the systems who are definitely not like that. But the system is a system, and the emergent motivation of the system and the emergent incentives of the system depend upon those who pay for the work. And if those who pay for the work, somebody said it's the man who pays the piper calls the tune. And that's exactly what we're getting. It's operating exactly as it should be, exactly as the people who fund the system want it to. And it's because they're all healthy. None of them are up against the wall with a degenerative, life-threatening condition. If it was, there would be a substantially different view and speed, coming out of research and medicine. There's a guy named Orrin Hatch. You might be familiar with him. He was a congressman out of Arizona, I think. And he was anti-stem cell. Embryonic stem cells was the big deal, 10, 15 years ago. And so we can't possibly have embryonic stem cells. And this guy was like totally against it. He was one of the leading anti-stem cell, embryonic stem cell proponents. And then his daughter became a type 1 diabetic.
Yeah.
Oh my goodness. He's sure, he's not against stem cells anymore. It took him 24 hours to change his tune, basically, I think. On a dime. So what we have is a whole bunch of gatekeepers and a whole bunch of control freaks, psychopaths, feeding off the sick and the dying. They're a bunch of Death Eaters. And I've been doing this for a long time. I had hoped in my mind 20 years ago that, this wasn't the case. I didn't just hope, I assumed it wasn't the case. I assumed that given the right opportunities and the right possibilities, that these things would just unfold naturally, that there would be this emergent desire. And then I wondered, why is this not happening? Why do we just seem to be going around in circles against the same problems? No funding and greed and all these always just seem to be the impassable thing. And it's because people are monkey-brained and they don't think long-term. They don't think that they are going to actually be the one to draw the short straw and get sick. Or if they are, they just put it out of their mind. So there's this psychological reality which our conscious minds do not want to acknowledge. When I very, very first, Ben Best, who is one of the cryonics, pioneers, wrote an article, I think it was one of the very first articles I ever read, called Life Extension, or Why Live at All, basically. And because there's all these people talking about, aging and only for the rich and all of these, absolutely bizarre, in a rational way, all these things people put in front of them so that they don't have to do anything. And the systems, the medical system and the research system, are emergent products of normal human society and normal human thinking. And normal humans don't have a survival instinct, is what I've found. When I was 4 or 5 years old and I understood that there was some mortality, things got old and died, I was horrified, freaked me right out, hated it, thought it was the worst thing, terribly unfair, couldn't happen. And then I thought, oh, well, by the time I'm needing it, but 40 or whatever, over time, there'll be something there for me and I'll be able to, take advantage of it. And of course, I got to be 40 and now I'm 59 and it's just like, fuck, 80. I'm staring down the barrel of an octogenarian, like another 20 years, I'm going to be 80 and that's not a good look. I don't care what happens between now and then. It's probably not going to do much about 80. And I thought, this is not going to work. And people do not have a survival instinct. They don't, not enough of us anyway, because there has been on the table rapamycin. There's been lots of indications that aging has been an approachable problem for many, many years, but nothing has been done about it. And it's because normal people just don't care. They don't think about it. They're too busy being distracted. What's that movie with, Don't Look Up? you know?
Yeah,
I don't know
that gave me
if,
anxiety. I was like, oh, I
yeah.
hope not, but I could see it. That
Anyhow,
was
so
not a
this is
fun
my,
movie.
yeah, this is the distillation of my thinking is that I'm running out of time. My parents are even shorter on time, which is a totally interesting topic is well, how can we all just write off the older generation? How is it that 99.9% of the people that I've met who are involved in the longevity space never talk about saving the lives of their parents or their older loved ones? This is not a focus. It's not even a fucking topic. It really, really blows me away. It's because everybody is just so involved with what's in it for me. And that is total monkey brain, especially when it comes to a common adversary called aging, which is killing us all and is going to kill us all the way it's been killing us all for millennia, ever since humans were around. We are within shooting distance of taking out the greatest adversary that humanity has ever faced, and we're diddling around, competing with each other for pennies. And I tell you, I've had it. I've definitely, but you're going to have to please edit some of these things out because I do not. I mean, I want people to understand how important it is that we collaborate, that we cooperate. We have a common enemy, and I don't care if you collaborate with me. You may not like me. We may not. We may have had problem. Maybe your personalities are different. Maybe we just don't like each other. It's fine, but work with somebody. Work with somebody, and don't be so self-involved that you think you have the same, or have the only answer, or that you have the answer, or the approach, or this and that and the other thing. We can't even measure aging properly yet. We still don't have the metrics. And so from OpenCures perspective, I want to gather the data that's capable of predicting if an intervention is working or not in short term, in the short order. So can we measure a biological system and get baselines, et cetera, and then do something to that system and tell the person whether or not it's getting better?
Yeah.
That is so fundamental, because if we could create a platform that allowed it, so my goal would be to have an in silico version of human health, a model of human health that we could do clinical trials on, ultimately, because human clinical trials are incredibly expensive. They take forever. And if that's what the only tool we have to develop interventions with and test them with, I am personally dead. Maybe you won't be, you might have maybe 10 to 15 years, there'll be something. But for me, it's acute. And for my parents, it's even more acute. And people are being rewarded for delaying things as usual. Delays don't mean anything to people who are healthy. So yeah, this is the lack of alignment of incentives of the customers for these things with those who are producing, and the fact that there's no feedback loop, positive or negative. There's no way for us to reward, it's researchers we like or the research we think is important. And there's no way for us to punish those who are wasting our resources and taking too much time. So fundamentally, so I'm working on OpenCures. I'm trying to source in the public using advanced diagnostics technologies to help them measure their health at the highest resolution possible, using things like mass spectroscopy. I mean, this is not a new idea, but standardization of data storage, standardization of the methods of sharing data, if anybody wants to share it, which is, again, a major problem. They don't want to share because they think their particular chunk of data is a $1 billion idea.
Like oil.
Yeah, and it's not. Our data is actually worth much, much more together from the synergies we would get from these analysis of the multi-dimensions than any of these pieces of data or dimensions of data are worth on their own. In fact, it's in the combination that you see a much greater emergent value. But so as long as you think that the thing you're holding on to is, worth everything, is going, it's phenomenal. So creating a model, in silico model, and giving that free, it's like developing a calculator. It's the first Texas Instruments calculator. everybody was doing long division and, with a pencil and paper and an abacus, and then somebody developed a calculator, and suddenly the world was able to do math, quickly and easily. And we're at that stage where in biology, where we need to have these tools that enable rapid, iterative discovery and application, and not just hang our hat on single interventions that we hope are going to have an effect and make us $1 billion, but then you still have the fact that you're going to die,
Yeah.
So the end in mind. So finding those like-minded people who know what's really at stake, is our lives and the lives of our loved ones, and that minimizing time is the thing, the only thing that makes sense. Because when you're on your deathbed in the hospital, you just run out of time. You may have a lot of money, you might have a lot of friends, might have a lot of other material things, but you do not have time. So that's the key. So creating a platform, sharing a platform that allows rapid iterative discovery, using the tools that should be publicly available and not hoarded and hidden, will allow actual interventions to be developed that do things that people can pay for, and then people should be paid out of the profits of actually reducing the suffering or the needs of somebody's customer. Up until now, it's just a Ponzi scheme where everybody just trying to Series A, Series B, start up this, start up that. It's a whole bloody religion around it, and nothing at the end of it. I've been involved with some companies now, 10 years down the road, pretty much, and millions of dollars and lots of conversations and thousands of hours of meetings and chit chat and all the rest, and canapes and JP Morgan conferences, and and none of it has been actually resulted in the reduction of suffering of anybody. Not a single fucking person has benefited from any of these people, and yet they're all still, having fun.
Yeah.
We're forgetting about why we're doing this.
Is it possible to align the incentives, even in terms of the people making the donation? So it's like giving blood. So they maybe they don't get paid up front, but as the data is used by other people, as you license it or people draw access to it.
So the incentive for me is people who use OpenCures for their health. They get their individual health results, which they can use to manage their own health, to improve their health. But then they pool that data. They also have biosamples, which I biobank. So we're creating a biobank. We create a biobank for them as well. So they own their data, and they own their biosamples, biospecimens. And when and if we get enough data and enough biospecimens together that it becomes attractive to research or industry, we will ask those people who own the data, it's like a collective or a cooperative, and say, would you like to participate in this particular thing? And if so, you will get this, but you will only get this if your participation results in an actual product or service. So this is a long-term thing. But there's lots of strategies. We could just pay them a little bit up front and, just to incentivize and get this gamification of keeping people's monkey brain attention going. So we have to have, the reality is we have to have ways of engaging people, including my own monkey brain, in order to keep this incentivized, this continuous engagement. It's high quality data that we're looking for from people who are disciplined enough to do the same thing the same way, have a little bit of self-discipline, and that's not a lot of people. So the strategy is, though, like, as you said, to help to incentivize, to align the incentives of the consumer with the research that's being done, and then reward that, you reward what you get, right? Or you get what you reward is what we need to do. So we need to really collectively think about that. What do we want? If it's money, that's what we're going to get. Because we're going to design all of our systems, the status quo. That's what the status quo is built to provide. It's not meant to find cures. That's absolutely hilarious. It's not meant to find cures. It's meant to maximize profit and ego for those people who invest in it. It wasn't that way when I first started. It was purely philanthropic because it was a joke to suggest that you could do anything about aging. But the more popular it's become, and the more you see these key opinion celebrity hounds out there hawking their wares and manipulating, policies and procedures for their benefit, I think it's shameful, frankly, what's going on. And we have 100 and some, as Aubrey has mentioned many times, we have 100 some thousand people dying every day. And that is what I'm focused on. That's what brought me to this whole effort. I know, and it's depressing because it's kind of it's changed my view about humanity, but maybe I was too idealistic and altruistic to begin with. I just assumed people had a survival instinct. I didn't want to die. I didn't want to die of aging, and I was willing to do, and I am willing to do almost anything to help avoid that, and that's what I've dedicated my life to. Doesn't seem to be the case with most of my. There's a core group of people who started out all pretty much at the same time through the Immortality Institute, which then became Longevity. And though that core group of people is still doing awesome stuff, and when we get together, we know why we're doing this, and there is something that binds us together in that reality of that truth. But the rest of them that came along after, it's an interesting hodgepodge. There isn't you don't have the same sort of purity of understanding of what's really at stake with a lot of those.
One population I thought would be really interesting in terms of just like synergizing, like where the research is happening, where there's interest, and at the same time where there's a population that already does a lot of studies, is in college. Like there's tons of people doing research in college. There's tons of people who, would love like an extra like $20 or something to like do something while also doing something nice. Like how many, like in neuroscience, there was like, you give people like a $10 gift card and they're like happy for a week. So like the costs are quite low. And at the same time, there's like new universities all the time wanting to do research. So you could kind of make a couple of hubs. I don't know if you're already doing something like that, but I feel like that's a really good opportunity to find people that are, already kind of in an area where where they can make a data lake for you, and then make use of that data lake immediately, and then find like some type of like shared licensing agreement with grants or something. I'm not in terms of like how grants work, but I feel like in terms of like how your stuff works, I feel like that'd be pretty clean.
No, for sure. I mean, I've got a charity called OpenCures Access, which I'm probably going to rename. I've got a for benefit. So there are multiple organs and multiple approaches with multiple incentives that are accessible for doing things. The educational appealing to sort of the youthful, would you like a slice of pizza in exchange for your liver? I think that would be an interesting thing to try. I think you have to keep, and anything goes. The best that what we need is people to measure their health at one point in time. We need health measured from different ages at different ranges. If I could go back in time and measure 25-year-old me and then compare it to 59-year-old me, there would be something different. I'm same genome, I'm my own internal control, but something has happened. Something has happened to this person that used to be a youthful 25 and has turned and morphed into this, and there's multiple, sensitivities now that I have that I didn't have back then. So if we could compare the metabolomics, proteomics, and genome with the genome, we would have an idea of the overlap of what is it between that. And if you do that with enough people, but then you have to go back in time and try and find a sample from that. Now, the question is, would we be able to take a whole bunch of young people's samples and then at every age, static slices? You're not following the same person, obviously. So you can have cross-sectional types of data sets. Would there be enough noise, or would you be able to reduce the noise, the difference in the variability between individuals enough to get at the root, some of these root changes in the system? And I think that there would be. So I think, incentive, but yeah, the incentivization, you need to find groups that are motivated who would take action if the barriers to doing so were lowered, or if the incentives are higher. And young people are more, idealistic. They want to help, they want to be involved, they want to learn. They're not so pessimistic cynical about the world because they haven't lived long enough to see everything that happens. But yeah, I think that would be a great suggestion, and I would pair that up with going into, standing outside of, going into old folks' homes and finding old folks who have nothing better to do. Maybe they want, but as soon as you want to start doing anything medical, and not even medical, anything that involves biological research is often conflated and lumped in with doing things that are medical. And they want to make sure, the systems are all put in place to protect the vulnerable and the gullible. And I guess the gullible are vulnerable, but from being exploited. But I am not gullible, nor am I vulnerable, and I'm still being prevented from accessing mass spectrometry to analyze my own health. Only that was not anymore, because now I have OpenCures, because I can now send my samples out to any company that has an assay that will accept my sample, and they'll return my results. But everybody's so frightened of regulation. And if you want money, you have to this is the beauty of not really wanting the money personally. You need the money for your company to expand and grow and do the good things that it wants to do. But I'm not motivated by cash, except in as much as that cash can minimize time to the development of therapies. So it's rather freeing to some degree.
So is the bottleneck money, or is the it sounds like it might be multivariable, but to what extent is it like you need like 1,000 people's data points over like 10 years, and then you don't have that, maybe only have like 10 people or something? Like what are the bottlenecks for you? Just if you had all the money, what were the bottlenecks in terms of just being able to build that foundation that we need?
That's an excellent question. So I was working with William Millard, who is who's the high net worth individual, that one of the few that I've met that actually has a brain. And he basically said these things should be like water. People should just get in the shower and they should just come over him. And he says, always imagine what would the system be like if money were no object. And so if that was the case, what would the ideal situation be? Well, you would want to speed. Minimizing time is the goal. So you would want immediately to go out and measure as many people as possible. And then you need to follow them a little bit, I think. Unless you can find patterns within, again, this is the problem with cross-sectional versus longitudinal data, is that you don't know if you can, the sample size you would need for cross-sectional data is going to be substantially larger than you would need if you were following the same group of individuals longitudinally, but then you're giving up speed for time. And there's the compromise there. But at the end of the day, maybe both, if money's no object, do both, And so it's just about finding as many people as you can, measuring them with the same assay. This has to be as accurate as possible, and produce as much data as possible, because we don't really necessarily know what we're looking for. And that is the problem, is that a lot of people, assume we know what we're looking for, or at least they know what they're looking for. It's their idea. It's mTOR, of course, or it's whatever, NAD, or all sorts of different systems. So that's what they want to look at. For me, I want these large, unbiased types of as assays as highly accurate as possible. And right now, the only tech that can do that is mass spec properly that I've been able to see. NMR, various other ones are coming along. But it's about measuring genomics, metabolomics, and proteomics, and combining those multi-omic data. So I would want to bring together the best brains who understand this data and how it's related, these systems, and work on how do we create not just a human genome, but the human multiome. So there needs to be really a global effort to decipher the human multiome. And I don't see why this isn't already a major push across the planet, but actually I do understand why. It's because the only reason why we wound up with the Human Genome Project was because Craig Venter threatened to patent the human genome with Celera Genomics. So we need to actually create a for-profit company and threaten the academic industry that we're going to, patent the proteome and the genome and the as long as they get a cut, they'll probably be fine with that. It's just it's monkey brain stuff. We have this evolved neural net that's meant for austerity, deprivation, and that is that's how our brains are built. And even in an era of abundance, which that's the disconnect we have with why we have so much stuff, but yet we want more. It's a fear of scarcity. Yeah.
Is there like a population size though? Is it like, do you need? I mean, this is all hypothetical, right? Because you don't know. But is it 1,000 people? Is it 10,000 people? Like, what do you expect it to be?
I think that's always the biggest question. Some people who study genomics, given genomic data, need to have very large n sizes in order to find patterns, meaningful patterns. That's not the same with metabolomics. So metabolomics studies with David Bennett at Rush University, population cohort size of 2,500, was able to show, various relationships for Alzheimer's disease, which were really remarkable. And it just falls out of the data, not ambiguous at all, just straightforward statistics. You can almost see it happening by eye. So there's a lot of low-hanging fruit in these things, even with small n sizes. It depends on the question you're asking. And, some of this, so this is why you need to get people who are specialists in each type of data and then bring them together, because they individually don't know what is very few people have thought about how do the different types of dimensions of data, how would they come together and under what context would they be really productive to bring them all together? How all of these questions and size. I think, if we had a whole bunch of people that were really disciplined and willing to be sort of like part of a cohort that was going to create this in silico model. How Craig Venter, when he measured his own genome and it became part of the first genome project. So I think as pioneers, and I'm attracted to the idea that it would be my data that I would go into building the first virtual, model of human health that would go on to assist in the building and the reduction of suffering of billions of people. That to me is that knowledge, that awareness. So I think 1,000 people, following themselves, and even less, 100 people. But you have to take it into consideration ethnicity and all the rest of this. But basically, it depends on what the level of it. So we use reference libraries, which are not, when we do assays here in OpenCures, we have a reference population, which of all ages, and both genders. So they're a healthy population, but there's 20 to 80 or 90 years old. And the CEO of Prodrome Sciences, who I work with quite closely, he brought it home to me because everybody says, so this is my result. And how do I compare against my peers? People my age, my gender, that sort of thing. And he goes, I don't want to be the healthiest person in a wheelchair. In an old folks home, how are you doing for 87? Well, I'm better than him. Mm-hmm. He's got drool napkins and then he's in a straitjacket. So, I'm better than him, so I think we need to decide as a group, who are we going to compare ourselves to? And that N will need to grow or contract accordingly. So if we open up the door and we just say we want to measure all ethnicities, we don't care. Obviously, we're not going to find out those differences between Caucasians and Chinese people if we don't identify those as reference populations. If we just include everybody, we're going to see the biggest levers that apply to humanity, not just that are the biggest levers in our genome. that apply to all ethnicities and all ages. So I like the idea of approaching it from there because that's the easiest. It's the easiest to do. But that's not attractive to people who already have some sort of horse in the race where they want something answered for their own reasons.
Yeah. Well, I think it'd be interesting if there was just like a bar on your website and it just had like a, hey, 30% to the thing, and then when the thing, kind of like when they do fundraisers and stuff, or a Kickstarter.
Yeah.
Because there was I forget the name, Signal Life Science Bio. They're another longevity nonprofit. I forget their name, Life Science IO. They're like pretty big.
Lifespan.io.
There you go. Yeah, and they were doing end of the year fundraising, and I was like, hey, you guys should have a page where it says like, hey, for every like 10,000 you get to do X, Y, and Z. And I was like, you should have that, because every fundraiser that I've seen that does something like that, they always go above and beyond what they want, because people can picture what they do. There's one called Herfer International where they say, hey, for every $10 you're going to give a family like 5 chickens, and that 5 chickens is going to this amount of eggs. Yeah, and that like people. I mean, sometimes like everyone's really busy, right? Like you're saying. Yeah, and they can just come in and then get a sample of like how helping this, even if it's just like financial, can impact people's lives in such a concrete way. Though you do have a really beautiful website, so I mean, you're doing good in that regard.
I had almost nothing to do with it. So I've got a co-founder who's now we're both kind of focusing on other things. So the OpenCures aspects, we've launched off of OpenCures into this something called it's going to be a new effort, which is moving closer to this type of a model of collecting data from everybody. But yeah, so Vincenzo Domina, he's been a fantastic asset, and I hope you have a chance to meet him sometime. Almost for sure you will, because he's involved with so many other things. He's quite a character.
Mm-hmm. We talked about data a lot. To what extent is machine learning or AI or any of these type of technologies being applied to this? It sounds more like bioinformatics, which isn't too far off from machine learning, I think. But how does it, under the hood, how does this stuff work?
Well, I think we're all going to be out of jobs pretty soon, frankly. I think
that's nice.
When hopefully, I mean, maybe we can move on to doing something more productive. But the Chat GPT, as well as Web GPT, and there's a few other.
Really powerful.
These tools are coming out, going to interface with machine learning. It's fantastic. Machine learning is exactly the kind of tool that we need to go into these vast amounts of data and pull out patterns, with that we're hopefully looking for. Like if we could define, 25 years old is model of human health, you have a whole bunch of healthy 25-year-olds of all ethnicities, just store their data, measure them in every which way, use a machine learning tool then to do the same thing and see whether or not what happens to you after that period. And it's going to play a role in a lot of ways in making suggestions, I think, to where to go. But I don't think it's going to just yield stuff, but it's going to be essential in artificial intelligence, as far as narrow AI for sure. We may, in the next year, or, I've seen like there's illicit.org is a sort of a research tool that puts out, it's just amazing. Research is going to be so easy for people. Of course, you have to check the results that the research engine gives you. But instead of having to wade through like 80% non-relevant results, you can only have to wade through like 10% non-relevant results. So it cuts down the amount of time. And of course, then it's going to draw its own associations. Anything that's written down in a reasonably even language structured manner is going to be amenable to artificial intelligence. And it's going to be able to infer, draw inferences, draw connections that are, people who already are focused on one particular narrow part of the science will never be able to find or never want to find. That's already been done. Stanford research, or I can't remember what his name is. Golly, it escapes me. He's one of the larger, he's a bigger name in multiomics. Just my old brain can't remember it. But they use computer models for diabetes, and they confirmed multiomically what we already knew about diabetes and the biomarkers, et cetera, involved, but they also proposed some new ones that we never would have come up with on our own without the help of the AI, and that were significant. So it's going to be a vast glut of, possibilities coming at us that we're going to need to, juggle and put together as fast and quickly as possible. And I'm sorry, postdocs, the human brain is, we can't keep up anymore. I mean, let's just be honest with ourselves as far as, we need these tools. We should be developing these tools as fast as possible. And, people should just be stepping out of the way and letting computers do all of this. I'm sorry, just get rid of that. And I will.
No worries. But it sounds like, so it's just bioinformatics in terms of how you interpret the data that you're currently gathering. It doesn't sound like you're applying any machine learning or AI so far.
You really don't need to right now. Yeah. I mean, the stuff that was coming out of David Bennett's work at Rush University with the smaller cohort of 2,500 people, just regular statistics, was able to pull out an awful lot of stuff. I mean, everybody wants to work with the latest and the coolest and the grooviest and, what the cool kids are doing. But if you really want to get the job done, you say, okay, what do we actually really need? And let's start there. Let's develop these other tools, but we can do an awful lot of good. We don't have to wait for them. We don't have to wait. We can actually, there's a tremendous amount we can do with the tools today.
So for open source, it sounds like it'd be really complicated in biotech. I mean, we've been kind of touching on it thus far. Are there other layers that we haven't addressed that, I mean, sometimes I don't even know the question to like understand because I don't know anything about how that works in that arena, but everyone always tells me it's very, very difficult to have any basis of like open IP because people, like we were talking about earlier, just wants to silo that so extremely.
That's because everybody wants everything up front. And they want it tomorrow, and they want to. Then they don't want to. It's proprietary, and it's competitive. It comes back to the root of competition, where you want to hide basic information, like the human genome. I mean, everything that isn't known, that becomes known. The first time the first person knows it, they are the only person to know it. Therefore, they are in a position of some value, relative to the other people. The problem is they overvalue the thing that they have and they hold on to it. And until it's obvious that, it's worthless or whatever. So we need to, open source sort of flips the model on its head and it says the end is when you actually, it's licensing generally. I mean, it's a licensing model. When there's a product, this is why it doesn't fit necessarily in the VC sort of world, is that you get paid when there's a product that's sold and a customer is served. That's open source. So when something, you can use open source, you can put the open source tools together and you can actually benefit somebody, and that's the licensing model. So you better have an application that's actually somebody's buying and paying for. Whereas here you have investors, it's just a big casino, betting on whatever kind of technology they want and hanging out together and having dinner together and talking about, it's a lot of it is the social networking aspect. But open source really lets information be free, and you don't make money by virtue of the fact that you're hiding something. You don't put yourself in a position of control by hiding the data. You actually put yourself in a position of vulnerability, at least if you're trying to hold on to the data for its own sake, or not data, but for the algorithms or whatever it is. Mm-hmm. The person who's open source knows that there's more value in accomplishing the goal of the open source than there is in making money off of the execution of accomplishing the value. So we shouldn't be making money off of health technology development. We should be making money off of health technology sales that actually does stuff. So all of the little pieces and tools and infrastructure, which each on their own can be a critical key core component of that process, but they're not in and of themselves a marketable tangible thing. That's why all of these scores, aging scores and biological scores, all this stuff, they're rapidly evolving too. So they're being replaced. So people who think that they have anything proprietary to hold on to that's going to be worth anything are going to be sadly disappointed when they find out that, somebody just leapfrogged them and quantum leveled them, with something else. And with computers, it's entirely possible. Everybody's still thinking old school that, as long as they can hide this information they've got, long enough, they'll have time to make $1 billion, but no, they don't. So if you have an idea, you're better off letting it go and moving on to the next idea as quickly as possible, rather than trying to spend 10, 12 years, trying to turn this idea into a moneymaker, because somebody's going to come up with something better faster, especially now that we have computers and tools that can help us evolve these things quickly.
How does that impact your approach then? If people are just going to keep moving on to ideas and they won't have a product, then yeah. Well,
no, you sell products, you sell diagnostics. Yeah. There is money to be made in serving people and serving customers. I have customers. I have a tangible bricks and mortar organization. I invoice people, and I look after them. I'm a retail person. That's why I understand the customer. I'm not divorced from that. The real reason why we exist. We can make money. It's just, what do I want out of my life? Do I want to be the king? This is the ego part of it. I have a huge ego, but I want to live forever. That's a little bit ambitious, I think. Or I want to live as long as I want to live. I should qualify that. Forever doesn't exist. But, there is, and we can work if we find other people who want the end goal, which is minimizing time. Those interventions, I want the interventions, and I want them as fast as possible. And I know that if I hoard the information that I need that somebody else could use to get us to those interventions faster, that is my fault. So I want interventions. When you think about it, it's teleological. It's incredibly important to remember that the motivation of why you're doing what you're doing, because that why is what you're going to get. If you want money, that's what you're going to build the machine to do, to make money. If you want CVs and publications, boy, it's all the infrastructure is going to be there to help produce papers. I want interventions. And I look at how do we do that? And it's just the same iterative sort of technological development cycle, but driven by a different intent. It's the intent to which all of the machinery is developed and put to, and is it actually, and then reward it. Then the rewards, the feed, it's all positive and negative feedback loops. If the behavior if the result is what you like, reward it. And too much now, the behavior we want is just more money in our. They don't think any further than these sorts of, frankly, lower order kind of issues or considerations.
Yeah, but I think they're like startups and like early stage VCs would like what you're building, because they don't have to reinvent the wheel in terms of the data set. They can just make the product.
Yeah.
There's a friend of mine who I won't name because I don't know if I'm allowed to name things. I gave them that idea, and they're then sharing their data with other startups, and it makes their startup worth more. So then they get a better valuation.
That's exactly, and more power to them. I'm not in competition with them.
No. I was just saying it's another mark.
I agree, but I know that that's not the case. But a lot of people think that just because there's an ego involved too, I'm getting fulfillment in my life out of moving in this direction because I see this particular gap that needs filled. And I'm giving my own kudos and pats on the back to myself for being so smart and, working at this thing that nobody else kind of properly sees. And, I'm smarter than everybody and more intelligent than everybody. So there's these narratives that are the childish ego plays. It's not that I really think those, but there's a tendency to do that. So I would love it if anybody who understands that we have a basic infrastructure, that we have to develop a language for handling and sharing biological health information such that it's seamless. When we want to share, we can share. When we pool, the data can come together in a statistically meaningful manner so that we can query it properly and not just get garbage out of it. So the point, it always comes down to the measurement, actually, and the accuracy of that measurement. Whatever it is that you're measuring, and you should have a number or something and a level of the accuracy of that measurement. And if you have all that information, just those pieces of information, then you should be able to create queries in a multi-dimensional way, which would be very useful. Open source, it's not because I don't like money and I don't like startups. I really love business and I love the strategizing and how to solve the problem. I just don't want to die.
Yeah.
And then I can open up other businesses. I don't know if health technology is an appropriate entrepreneurial kind of outlet.
Mm-hmm. How do you know, like, what all data do you collect, and how do we know that that's the right data to collect?
Well, that's a priori. You cannot really say that. The value of the data is always relative and it's always changing, and it depends on the question being asked. But the thing that you need to have is accurate data. Let's get some good data first. And then we can look for patterns within the data for particular questions. And then, so the type of data, the amount of data, the size of the data set, all of this, it all depends on the question that's being asked. If the question that's being asked is, how do we reduce the amount of accumulation of cross-linking in the thing? So that's a very specific question. It's got specific targets, specific biomarkers. And does the data that we're collecting contain that information? So we have to, for me, my question is, what are the biomarkers different? What are the differences between biomarkers between healthy individuals, young individuals and old individuals, healthy, young and old, without having overt disease, get as close to old age as possible. You don't have any chronic conditions. All of your biomarkers are still within the norm of the reference ranges, but still, what is the difference between these populations? And how do you get that older population to look more like the younger population? And you need a lot of data for that. And often you don't know what you don't know. So you measure in an unbiased way, and then you start off with the biggest net possible to get as much data as possible and collect it consistently. And then you can find patterns like the plasmalogen story that came out of the Prodrome Sciences study with David Bennett, as I was referring to before. Plasmalogens became, was one of the most important markers for extreme longevity, but yet it's one of the things that nobody really yet knows. All the literature is there. Correlations of plasmalogens levels with extreme longevity is well known. But the problem is that there wasn't an exogenous source of plasma. There was no way to manipulate the levels. Internally, you couldn't eat it. It's destroyed by your digestion. So all the evidence we had was just correlative. And so how do we know whether or not taking plasmalogen supplements or elevating plasmalogen levels in somebody who's got old would help? And so now we're on that. But that took a long time just to, it took 4 years to just identify plasmalogen as the marker after the measurement of so once you have this information, it's just that long. And it was just realizing that if things take that long, my goose is cooked personally. I'm not going to make it. I've already had cancer, already had one strikeout, it's time is the most important thing again. So how do we rapidly iterate and create, and it's going to not be any magic. There's not any magic to it. It's just grunt work, basically. A lot of people measuring data. The China's doing a great job in that, in order to, at a concert, they will get all of the people who attend the concert spit into a tube. So they want genomics on the Chinese population. The Chinese government just goes and says, okay, spit into the tube. And they do all this genomics. Why aren't we doing something similar for multi-omics for everything? Because there's no corporate incentive, and the academics are all interested in their own personal passions.
Yeah. I don't know to the extent the average person will start thinking there's like chips in it or something. Like with COVID, I don't know if you remember that. When I got the shot, I kept saying that I want to buy Microsoft stock now out of nowhere.
Yeah.
Sometimes people wouldn't tell I was joking, but which is to, anyone out there who had concerns, hopefully you spoke to someone, you had those concerns alleviated. I'm curious, is there anything sorry, is there anything pre or currently in testing that you're excited about other than what we just talked about? It's like a lay of the land.
Well, I think so. Aging is a combination of lack of regeneration and too much destruction. So we have a really good homeostatic balance while we're growing, obviously, and we get to adult body plan size, and then gravity takes over. After we're thought out of a rocket, and then we hit our apogee, and then we start to decline with entropy. If there was some way that at that peak we could maintain our informational integrity, in other words, the repair systems keep things together, we could probably float quite a bit. We could increase the arc quite a bit. We may not make it to longevity escape velocity or whatever, but at least we could tread water a little bit longer and still enjoy life. We don't know actually how far we can push our own repair systems, our own regenerative systems. So one of the really important topics is Altos company, Jeff Bezos, these transient RNA expression of the yamanaka factors with the reversal of age-related phenotypes and epigenetics and function, actual function phenotypes. That, to me, is proof positive that we should be able to do something like that in humans. And how do we do that? Well, does it require $2 billion in watching someone else like Jeff Bezos do it and take control of it? Or, and then paying through the nose and another 25 or 30 years before we actually, the general public or anybody else other than a billionaire, gets access to it? Yeah, I'm very excited about that. Luckily, it isn't that difficult to do. And the only thing protecting these basic, these are like the height of the technology right now, but next year or 2 or 3 years from now, they will become mundane. And even the people developing these things and trying to invest in them don't realize how fast things are changing, but that's a good thing. Otherwise, they probably wouldn't invest today. So I'm all for Altos, and let's go for it. I think they're in an area that's really good. There are other companies which are following sort of the same paradigm. I believe we will be able to harness the capacity of the body to regenerate, and we'll be able to stimulate regeneration even in older individuals, sort of Irina Conboy and the Conboy lab have been saying that for many, many years. When you're old, it doesn't mean, and your body's having problems, it doesn't mean it's incapable of, doing better. And in fact, the fact that an old person an old man, at least with a relatively old woman, can have a perfectly healthy, youthful child, just tells us that everything is up for grabs. It's just a matter of people want instantaneous reversal of age. But we don't get old that fast. Mm-hmm. It takes a long time to get old. And I think we might be looking at approaches that reverse aging in at least this same length of time. It might take even longer. So patience, I think, is going to be important.
Mm. I'm curious what your thoughts are on the thesis or on the current work of some of the people I'm about to read, starting with Aubrey de Grey. You mentioned his 50 chance of Lev. What do you think of it? And then just like general sense of it.
Well, I know Aubrey rather well. We don't talk a lot anymore, but I still subscribe to the idea of the robust dose rejuvenation. It was one of the things that I worked on with him or very early on, one of the early concepts when I was the executive director of the Methuselah Mouse Prize, or the Methuselah Foundation. But for me, mice are not people, I think. It's just, and I think, again, it's time for me is the most important thing. If we have to do something in mice and then replicate it in humans, I think when I would prefer to look at what can we do that would achieve something similar, because the goal of, I think, robust mouse rejuvenation is to give the industry an incentive to change their minds, right? Is to sort of change the way people look at aging as being malleable. And if we can do it in mice, we should be able to do it in people. Given what I've seen of survival instincts, it's just monkey brain, not very intelligent behavior. I don't know if, anything. I don't know if anything actually. It's sort of like don't look up again. It's just like there's an asteroid coming to the planet, it's going to crash into, and some people, they just don't care. They just don't care. And I think the majority of people, they just don't think it personally impacts them until it's actually in your face, just like cancer was for me, it was in my face. It altered the way I saw things. And that is how I think people learn and behave. So I don't think robust mouse rejuvenation would achieve what Aubrey hopes it would. But, I think it would change an awful lot of minds. It may catch an awful lot of attention, and that eventually may result in that. But I don't think the public are going to be that fascinated by a mouse that lives very long.
Isn't the process we're supposed to do it animal models, then do it in humans, so that there isn't like adverse effects?
Well, I mean, but I guess it depends. Well, that depends on if you think that mitochondrial allotopic expression, et cetera, are things that I think that we need to do stuff that's low-hanging fruit now, because I'm personally a customer for it. I'm not personally a customer for mitochondrial allotopic expression. I want to do things that will impact my health today to keep me healthy long enough to take advantage of the things that are going to come along later. So I'm not saying that it's not worth working on. I think that in the long term, but I think there's an awful lot we can do in the space of health maximization that will teach us what are the things that are modifiable and what are the true, targets of those. It's sort of like, let's let the tide go out. Let's look after all the things that we can look after, and the only things left to emerge will be the appropriate, targets that we need extra technologies for. But like altos and mRNA, this expression. So these are all, I see them as steps. So I'm going to do everything I can today with what is available today to me to do that. And there's some really simple stuff. And mass spec is just nutritional based. I mean, people are wandering around low in omega-3s and, low in their plasmalogens. They don't have good choline levels. There's a whole bunch of really important metabolites, basic building blocks, which if you are deficient in for long periods of time, your body starts, it's been making choices. It's sort of like building a house. And if you're building a wall and it calls for 2x6s, but you don't have 2x6s and you have 2x4s, well, your body's going to put in the 2x4s. And then you're going to have a wall that's just not as strong as it should be. And it's the same thing with all of the choices your body is making. If you're not optimally nutrition, you are actually causing a lot of the problems with ignorance that you could. So that's what we can do today, is modify our diets and lifestyles to really put ourselves in the best position possible. And then we will know an awful lot more about, the other types of technologies.
It sounds similar to Harold Katcher, if I'm saying his last name right. The quote is, the cell age is determined by its cellular environment versus something more deep than that. I was going to ask you about his work and what you thought of it, but it sounds like you and him have a similar thought process.
I think so, for sure. And I think one thing we tend to forget is that our environment is us. Our bodies don't end where our skin ends. We are part of this living system, which is a community and people, but people tend to just define their system, their biological system is everything that's happened under their skin, but not really. And that we are a very complicated system, and we focus on some of the things we can focus on, but there's an awful lot more going on. And Harold is but I think we agree on many points. Yeah.
What do you and I've recently, in the last couple months, come to this guy's work, and I've been having so much fun reading all of it. But his name is Michael Levin, and he's about morphogenesis and bioelectricity. He has really interesting stuff that he's been working on, and I'm just curious what your thoughts on it as it relates to aging or just general.
Well, I know it almost gets, when you talk about electricity and magnetism, you're talking about almost metaphysical kinds of things. You almost, because they are not matter. They're not they're actually the forces, the photons and whatever that go in between. So they do have some mass, but they're not really real, so to speak. But Michael Levin's work is, I was looking at, there's, where you look at axolotl limb regeneration. There's some early work that was done before. And if you cut an axolotl's limb off, it will regrow. Everybody kind of knows that. Yeah. If you take the motor neuron from that would innervate the limb, and if you make a cut in the side of the axolotl, and it'll grow back. If you take the motor neuron and you attach it to the cut, it will grow a limb there. So there is something about the supply of the electrical impulses from the motor neuron that tells the cells that you've cut that they have to change their regenerative plan from skin to actually creating a limb, which just blew my mind. And then I started looking at the biophysics of fields, as in embryogenesis and embryonic development. And you can see that even before the molecules arrange themselves, that there's a field that is advancing almost in front. It's leading the development. So we don't know what is happening, but it's almost as if it's the pattern of electrical charges that are creating fields and the conductance. Then the molecules, the biological molecules, come in. So we haven't really even touched. It's so hard to measure that sort of thing, and I don't think anybody's been. It's a little too woo-woo for a lot of scientists to think that, that this is so important and probably fundamental to life, maybe even existence, at all, because this stuff is happening, automatically. And maybe biology follows, electricity and magnetism rather than the other way around.
It was interesting. One of his talks, they stimulated a part of, I think it was a frog embryo, to grow an egg on its spine, and the eye connected to the spine, and the frog could see from it. It was just a sensory input. It's like, that's wild. This is like witchcraft. It was so cool.
It's very flexible toolkit life has.
Yeah.
Yeah.
It's crazy.
It is. It's these kinds of holy F moments, when you see stuff like that, it just it's incredible. It's like you're getting a peek into something that is foreign and not easy in our experience to really understand. But once you get it, it kind of opens up a whole possible new way of interpreting things that we didn't understand, that maybe they can start becoming more clear with this new way of thinking.
Mm-hmm. There's a paper that he wrote on bioelectricity and cancer. I'm reading it after this call, actually, and I thought it'd be really interesting because 200 years ago we leached a president to death, and we thought that was we were doing the right thing there, and so now we do chemicals and all these harsh things. I just wonder if there's going to come a point where we just have to put an electrode in there and it just give it a signal to shut off and kill itself at a certain rate so it doesn't overwhelm our system and kill us.
Non-invasive. Yes. Non-invasive is going to be, once we know, so I'm currently, it's a lot easier to destroy things than it is to create things. But, right now there's a new ultrasound type of device, which is able to break up scar tissue. And that's without cutting. Then there's the infrared light, which stimulates mitochondrial function, and which is red light therapy, which is being shown to be beneficial. And actually, it's even being shown to be beneficial for caps people were wearing through their skulls for some reason. So there's also transcranial magnetic stimulation and radio focusing, laser focusing of radio waves. And a lot of this is easier right now to just burn things and break things up. But once we get to figure out, like, there are resonances within these molecules. So when they can regrow bone in your jaw with a particular frequency, and there are some ultrasound systems which can stimulate stem cells at a particular frequency to help heal hard to heal bones. And so there are machines that we already know that these are important non-invasive radiation, not necessarily radiation, but photon waves or sound waves or these sorts of things that our biology responds to these types of things. Not necessarily drugs, maybe so finding out what those resonance frequencies are, which the receptor channels for calcium and magnesium on a particular, and then target that sort of laser, radio wave laser to a particular tissue, particular spot. You might be able to just trigger apoptosis, but we got to learn where are the buttons, where are the switches at that biochemical level, and what do they respond to? Who's doing that work? I don't think anybody is, but I think it's a viable hypothesis. I think Michael Levine would be sure be able to tell us who in a small group of researchers on the planet are doing that kind of work. I think he's probably being seminally instigating an entire revolution in this work. I don't know of anybody else who's been doing anything like it.
Yeah. Well, when I was reading about axolotls and like people trying to replicate the features in humans, it's always like, can we do genetic engineering on a human to give ourselves a similar function? It's like, well, why can't we just create like the structure and figure out like what chemically is going on or like what's going on and like regrow it? Like we put a hand in a vat and it just like slowly gives the environment where it regrows. And so it feels like intuitively what would feel right versus like having to do something really complicated, which is like, affecting the DNA of a billion of different things, like in a hand, just like creating an environment where the hand can regrow.
At the end of the day, given a bionic, indestructible hand or a fleshy, injury-prone hand.
I want the fleshy one.
You want the fleshy one?
Yeah, I want my hand back if I don't have a hand.
God, no. Everything. This is all. I mean, after you've been through cancer maybe a few times, or what, our bodies are barely, they're pretty durable, but they're not meant to last. And, I would prefer something a little more durable, or maybe a little more flexible, a little more attachments, a few more accessories. I'm not.
So you'd be like the bionic man.
I'm not married. Yeah, I'm not married to this biology at all. I just know that I have to keep it running long enough to be able to see the replacement stuff going along. But I do think it's going to be a race between mapping, uploading your brain into, can we replicate our identities within a different substrate, and the philosophical questions of whether or not such a copy would be you is really irrelevant to me, because as long as it thinks it's me, I'm quite okay with that. And I think we'll have that technology maybe sooner than we think, then we are able to actually extend life. I think before I turn 80, I think in the next 10 years, we're going to see human level intelligence and computers, and then finding a way to map our human level sort of human. And in there might already be there, Elon Musk and various other things. I was working with a researcher at the University of Alberta who had developed, unfortunately he died before he could finish his work, but he developed the nanotransistors, which were capable of both stimulating neurons. They would attach themselves permanently to neurons, and they would receive a signal and cause an action potential. And if there was an action potential, they would send out a signal. So every neuron would be IP addressable. And you could see, you could map the network activity of your neurons in real time in what you were experiencing, record them, and then have it played back. It's much easier to see that being done now than curing aging, frankly. It's because its neurons can be stimulated and wireless signals can be sent. And once you're able to record and replay the actual living experience of the activity in a person's brain, that's really all that the body's meant to do, is have that thing that thinks it's you, able to be conscious. And that may be possible to actually bring consciousness into maybe able to invent consciousness than it is to cure aging.
Have you ever seen the movie The Prestige?
I did, yeah. That was I've seen it twice, and you know what? I'm going to watch it a third time, because the second time I watched it, I barely remembered it, because I started seeing so many different things. And
yeah, he had fun in that movie.
Yeah, that I didn't see in the first one. But that was with Michael, the older actor. He was
Batman. Batman, yeah. And then Hugh Jackman, right?
Yeah.
Well, in the end, we find, this isn't a spoiler for you because you've seen it, but in the end, we find out that like every day he would drown one of himself, and the other one would teleport up there, and he never knew which one was going to die and which one was going to live. And so with these things, isn't it? Even if you can make another AI copy of yourself, like this version of you is going to die. Doesn't that bother you? Or wouldn't that bother you? Like, as long as it's like one version of you.
Yeah, well, I think does our genome care that it's dying, and as we're propagating it through our children? I think it would be the same thing. It would be sort of, I came into being, if I was the clone, I came into being as a result of this biological entity's interest in my coming into being. So it would almost be like a parent-child kind of relationship. And you would be sorry to see your parent die, but this is the way of all flesh. There's no getting out of it unless we can find ways of keeping this homeostatic balance going forever. And even then, you're still vulnerable to all sorts of problems, mechanical problems. So philosophically, I just know that I exist, and I'm looking through this. And as long as some aspect of that continues, I would be okay with that. Personally, if somebody that thought it was me lived on in a computer, I'd say, okay, hasta la vista. I'm like, what was that one ring with the elves heading off to the west shore or something like that, jumping
to the Undying Lands.
Yeah, exactly. So I'll willingly jump on the boat. I faced death with cancer. I'm not worried about dying. I'm pretty sure that we're pretty ignorant about what reality is. Don't think we really have a clue. I'm not, certainly not an atheist. I'm absolutely 100% not religious, but I'm a scientist, and what I do know is that we know nothing about what's really going on. And, this is all not entertainment, but I look at life more almost like a Monty Python play now, especially after seeing the world unvarnished and the crazies howling at the moon and the rest of the smart people kind of going, oh my God, we're going down with the ship with these people. It's I'm having the time of my life, and it's very freeing when you're not worried about it. I just want to see suffering reduced. I don't think that the experience of life should be primitive and rude and crude. I think we should be elevated, and we should be working towards creativity, helping each other create a better world rather than tear it down. But, yin and yang, there's going to be, I realize that this is true. Evil exists, good exists. I just happen to be a little less evil.
Mm-hmm. So I know we're going over our time. I have like 3 questions left, but if we need a cap.
Don't worry. I don't need to cap. I can go for a little while longer. Yeah.
Okay. Sorry. I appreciate that.
It's partially my fault too. I told you couldn't cut me out.
Well, I enjoy listening. So a quick one. The next two are, I think the next two, yeah, the next two are from listeners. One person was asking, will you have like an internship program for the summer? I think it sounds like they're in a PhD or a master's program, and they're just looking for ways to be involved in longevity.
I've done this. I've taken on interns before. For me, the intern would have to be very special, because, and I know that they are out there. So just if somebody is pumped about what I'm doing and we talk and they're even more pumped and they want to work for free, come on over. Happy to have you.
And what the best way would just be like info, the links on the website?
Yeah, just info at the mail and the website. Get in touch with me personally through LinkedIn, Facebook, whatever. I'm pretty open and available for people to contact me if they'd like.
And then, what are your thoughts on medical mushrooms like cordyceps and lion's mane? I know lion's mane. I've not heard of cordyceps before. I grew a lion's mane, so I probably should know what it is.
Yeah, the funguses are something which I have not dug into a lot. The most thing I can do is just be so appreciative of the fact that they've been around longer than you carry at most multicellular life.
Yeah, they're really closely related to us.
Yeah, they're clear. Yeah. And so there's an awful lot about them, which I think would be which we don't know. So mushrooms, I think, are probably very good, but I love mushrooms.
For eating.
For eating,
not medicinal.
I think lion's mane I've heard is quite effective. That's a really good big gap in my knowledge that maybe one day I'll have some time to dig into.
Yeah, I've grown lion's mane, but for some reason I just never ate it. I just liked growing it, and then I learned how much it costs, and then I feel really bad for not eating it. But
well, I've eaten it before, but I didn't like it. I didn't like the texture. Yeah,
I thought it was supposed to taste like lobster or something. It doesn't taste like that?
That's probably why I don't like it.
Okay. Lobster used to be prison food, like something that even prisoners would want to eat.
Down at the bottom feeders. Yeah, exactly.
Yeah. So this is a David Sinclair quote. Only 20% of our longevity is genetically determined. The rest is what we do, how we live our lives, and increase some... God, I'm like almost joking. Sorry. How we live our lives. Everyone listening, I'm trying, man. I have had the flu. Kevin has been very forgiving. So restate, the rest is what we do, how we live our lives, and increasingly the molecules that we take. So the question is, and I think we've talked about this, is like the undercurrent is like things that we can do today to improve our longevity and health span. And so I was just curious, what are some of the things that you're doing, to maximize those things? Not like the interventions per se, but just like your health, like exercise, nutrition.
Well, the first thing is, I mean, I've always said, if people did everything their grandmother told them to do, they would be well ahead of the game. Get your exercise. It's the most important thing that you could be doing. The absolute single most important thing you can be doing beyond food, beyond supplements. The next thing is sleep, because although exercise is good for you, it's actually not. It's the recovery from the exercise that is good, and you recover from the exercise when you sleep. So exercise is really good if you can recover from it, because exercise is a stress. It's actually hurting your body. So people don't separate the two phases. They lump them all together, and they forget that it's the recovery that's most important. So stressing your body out off of its homeostatic balance with temperature, cryogenics, or whatever, cryotherapy, hot sauna, all sorts of exercise, physical, manual exercise, hypoxia, hyperbaric. Anytime you're taking your system, which is very happy with the status quo, and you push it off of its center, and then you force it, you stretch it, and then you force it to get back. It snaps back and it goes, oh, holy shit. And then it starts making itself stronger and more resilient. It's like an adaptation so that it can withstand the next time. It's assuming that there will be a next time. So doing all sorts of things to keep your body sort of off balance and uncomfortable. And that is the last thing most people want to do. They want to be comfortable. They want to be, so this is, how can we reprogram our brain to like discomfort? That is something. So meditation, cognitive therapies, these sorts of things. Occasionally, mood altering substances might actually go a long ways to helping bad, sort of not comfortable experience become more comfortable. And that's something that, some people can do, but stuff that is healthy for you, or at least not unhealthy. Food, you got everybody going off their gourd about ketogenesis and whatever, caloric restriction, and everybody's got their favorite kind of thing. And some people stick with it and they find out that they're actually more sick on their diet than they thought. So variety, diversity. The one thing is stay away from insulin spikes, stay away from sugar. It's the white death. If insulin, or I should say, if sugar was discovered today, it would have to go through FDA approval. And it's
intense.
It's killing people every day by the millions almost. It's incredible. And there's sugar industry, happy as a clam. Let's not, don't ruffle the waters. They're more evil than the tobacco industry, because it's
in everything too.
It's in absolutely everything. So sugar, or whatever you can to limit or eliminate it from your, especially added sugars, gone.
I tried doing that. I tried eliminating sugars from my diet, and literally on like a can of tomato soup, like a full can of tomato soup has like 200 grams of sugar. It's like, how do you even get that all in there? It's like everything. It's egregious how much is in everything. And the fact that our food pyramid is designed by the corporations is actually, and with the lobby too
of the politicians. I mean, we were all at the mercy of this stuff. And once you see the way things are really working, it's hard to trust anybody anymore at those levels, that they actually have anyone's best interests in mind other than the people who are running the show, pretty much. So anyway, so diet, sleep, exercise, social connection, if you're the type of person who thrives on it. And I sort of go back and forth, that I need to recover from social connection, but I certainly enjoy it. It pushes me off of my balance and challenges me, and I learn a lot. And you don't learn a lot unless you are actually talking to other people. So if you want to live in your own little insular world and looking in a hall of infinite mirrors with your face on it, then stay at home. But get out and enjoy life. And that's why we're here. That's what we're trying to continue on, is the experience of doing the right things. So I take a whole bunch of supplements now. I never used to. I also wear a wearable, a Whoop band. I hated wearables before that. They always would get caught, or they were funky. I don't even like wearing rings because they tend to get caught on stuff. But I'm addicted to my Whoop band because it tells me how good my sleep was, even though I know how good my sleep was. But it's nice to get those metrics and the graphs. Also, I'm able to now download that data and import it into my OpenCures profile, and I can match it up with the different other events which are occurring in my life. So it's kind of interesting to see my biomarkers going up and going down according to sleep, so wearables and supplements, but usually only supplement if you actually need it. There's anybody over 50 should be taking mitochondrial support, supplements of some sort, acetyl L-carnitine and these kinds of other things, especially if they're feeling kind of tired and lack of energy. That's probably a good indication that their mitochondria and their neurons are not, being as efficient as they might want to be. And you can actually improve that efficiency through supplementation. For how long will that last, before, the inevitable goes on? I don't know, but anecdotally, no, not even anecdotal. I mean, we need to be able to have these functional tests to show definitively that, these supplements are improving our cognition, they're improving our reaction time, and these other things which can confirm what I know to be is that I feel better. I feel better. I don't need a nap in the middle of the afternoon, which is pretty common before I started taking supplements. And so those are the things that I do. I also, when I have an opportunity, will volunteer for clinical trials that have, like the growth hormone, thyroid, regenerating my thymus gland was one of the things that I did with Greg Fay's Grim trial. So just that's what I'm swimming in. It's just fun, I don't know. Try to take advantage of all the technologies and the networking and the connections. Be educated and be curious, and continue to learn, and don't ever take what somebody says as being the be all and end all. You can get excited about it, but boy, I've seen an awful lot of things to get excited about over the past 20 years, and they become either mundane or yesterday's news, or they never turn into anything, or they're still actually unsolved. They're still a mystery. NAD, or rapamycin, this was like 2007, 2008, and it's still not properly studied in humans. This was the real depressing thing for me. It was looking at rapamycin. I was talking with, who was the director of the NIA at the time, Felipe Sierra. So we were in Tahoe at a conference, and he had just taken over the position of director of the NIA, and we were sharing a condo. And he was, of course, asking, how can we get more funding into aging research? And I sat and I thought about it, and I said, well, this rapamycin thing, that increases the maximum lifespan of mice for the first time in human history, isn't that a pretty big deal? Shouldn't this be like a poster child for aging research, and you guys could be able to take out and shake the pom-poms and get a lot more people excited and interested? And he goes, yeah, but they never did capitalize on it. They never did. It's the natural propensity for aging researchers and scientists in general to not want to be associated with pseudoscience. Really, it's this risk aversion
very dangerous.
Caused the delay in showing the rapamycin, and it's the lack of patentability of rapamycin which prevented the corporate environment from taking advantage of it. So here it is, one of the most promising things for human longevity ever discovered in human history, sitting there like a volleyball in the middle of the court that nobody wants to pick up because they're afraid. But yet it's just, that blew my mind that this was where it was at when it was given to them on a frickin' silver platter. And they just turned their nose up at it for all sorts of stupid reasons. And so we're going to be entering an era, I think, where we need to rapidly put things together and take advantage and find out that, test things on rapamycin, metformin, all of these other possibilities now should be tested. And the people who are already taking these things off label, we need to create ad hoc community sponsored clinical trial groups where we measure our results. We measure the impact of taking these longevity drugs on our own selves and in the same way as everybody else. And then Keith Comito is very big he's at lifespan.io, and he's really one of the big proponents of community sponsored clinical trials using, just individuals crowdsourcing, because there's no reason without our suffering, there is no need to develop a medical therapy. No need. If nobody suffered, there'd be no market. So without our data, they cannot develop any therapies. So the sooner that the people who need the therapies use their data to help reward or create, positive feedback loops, the better we will be. And that is going to happen. And it's going to happen sooner than we think, that people are going to be able to aggregate their data together and create a data marketplace, like a stock exchange. There'll be data sets of Parkinson's patients who are, out there measuring their own selves. They're measuring their health every day. Why the hell shouldn't they? Why should they not be afforded the scientific tools, the ability to measure their health with scientific tools and collect their own data and then make their data available as a group to the highest bidder? There should be no, you are a data generator. You are a data generator. I'm a data generator. Together, we form a small group of two. Let's just do, the problem is that all of these monopolies exist on the equipment and the expertise, and the normal people are just passive, supplicants to the altar of biotech, and we are not involved. Our duty is to die. That's really what it is. I am, totally fed up with the system. So I hope a lot of other people are too, and I think they are. I'm not the only one trying to advocate for empowerment of individuals. You would think in the libertarian community that this would be right up their alley. So I think there's going to be a lot of discussion as to how do we maintain privacy, how do we keep our data and hold on to our data and get the value of our data that everybody's been feeding off of for free for quite too long.
Mm-hmm. Actually, related to one of the things you were just talking about, rapamycin. Sorry, when it's written down, I have like mild dyslexia. But one of my listeners asked if you could guess on its effectiveness and dosage and frequency of the impact. So basically, it's like, is it as big? It sounds like it's a pretty big deal. I don't take anything.
It is a big deal.
So
it is a big deal. But there is a ton of information on its dosing available now. But I think you can probably go to Matt Kaberline's, Matt Kaberline with his website with the dog rapid trials. Pfizer, it was prescribed. I think people have tried a whole bunch of different doses. I think 2.5 milligrams every second day, kind of thing is, but it really is, we should wait for agelessrx, which is a telemedicine company, and they are prescribed longevity drugs, metformin and things to the public through the online and online. They not only are interested in sustaining themselves and making a profit, but they're also interested in giving back to the research community. So they are running a rapamycin clinical trial with before and after with some of the people who buy the product from them off-label online for longevity purposes. So I would wait for their study. I actually do. I'm working with them, and I help OpenCures is doing their logistics for their biobanking and a whole bunch of things. So we're having a great time. And we're going to see what the results are about the biobank through the biobanks when the biobank gets full and all the participants are done. We're going to send that off. We're going to get some data back. It's going to be made public, and the dosages will be made available and the effects will be made available. It's probably going to be one of the first trials ever to do this, which is like mind-boggling. And I can't believe it's taken this long. So the listener can be sure that they can, whatever if they're going to try it, go to the agelessrx website. There's a protocol there. There's a number of different doses on different arms. They can even sign up probably and participate and gain the benefits of a lot more information than just what I know. That's for sure.
And then it doesn't have to be longevity related, but what are some books that you'd recommend people check out? It could be like favorite books that you like to recommend to other people, like as gifts, or just in general.
Well, since the advent of the internet and lack of time, I don't actually read a ton except for the occasional paper. But I found Asimov's Foundation trilogy. It sticks in my mind. Is one of my favorites, and now that it's been turned into I think Apple TV has it as a special. I haven't watched that much of it. I don't know. I mean, it's a TV thing. It's a movie thing. I think the books were better. Accelerando was a good book that I'd read, and pretty much everything that Ray Bradbury's ever wrote. A lot of the sci-fi stuff. It's been a long time since I've actually read some, really taken the time for reading. But Yeah, that's about it. I don't have a ton of recommendations on books.
Well, a book for you that I recommend is Never Split the Difference, because you have to do so much negotiating. It's a great book, and I recommend it to every one of my science friends. And of a population, the scientists really appreciate it in particular. Like, it really helps their day and stuff. Have you heard of this book?
No, I haven't. But what's the punchline? Because I probably won't read it. But go ahead. But I will look for it on Amazon. But
No, I recommend it. It's really good.
yeah. Well,
That's it. I'm not making a joke.
But no. But what is not the? I meant the punchline of the book. But that was sort of facetious. What is the main premise or the?
It's a book about a guy who used to do hostage negotiating, and so it's how to ask questions to understand what people actually want.
Excellent.
Yeah, most people don't. If you ask the right questions, people are more likely to tell you things. And at the same time, for the most part, people tell you what they want if you ask right. Like, there a couple of my friends were they're biotech startup founders, and they were working with like Roche or whatever, like these big people, and they use the techniques to basically figure out like what do they actually care about the person I'm interfacing with. And you would think it's like, oh, like if you're like new to it, you think this is about making the best product and helping most people. It's like, no, I need to have you have this type of results so I can get my quarterly bonus, so I can get this promotion in 2 years. And it's like, okay, great. Then I know what I need to do so that you are always being a hero. So it's like that type of thing. So that's the tenets in the book kind of help people with that type of thing.
It's brilliant. Yeah. So that's kind of like the realization that what people say is almost if it bears any resemblance to what it is that they're actually truly saying, or what your expectations would be, is almost accidental.
Yeah.
So yeah, I think for sure it's a great to keep that in mind and to learn how to write or ask actual structured questions. I think is a good thing. Will actually take a peek at it. That sounds
it's a quick book. The audiobook is great too. And they even have a master class if you want.
And what do you want?
What do I want?
Who is Lowell Thompson? That's what I want to know. Like,
I will let you know when I discover him. It's a continual evolution. Right now, I want not to be sick. Yeah. But another recommendation, because it sounds like you have like a lot of stress in your life. I think you'd love like a Miyazaki film, like a Nausicaa in the Valley of the Wind. They're such beautiful stories, and I think they would just give you a little bit of hope with everything you got going on.
I actually have never been more hopeful, but at the same, it's very much a Schrodinger's, type of what you get out of me depends on the time of day and context. Yeah. And so, yeah, I can sound cynical, but it is quite deliberate. And I could also sound very optimistic. But in this case, if we're talking about interventions and how to do it, how to get them, if we're just talking about life and, beautiful creativity, music, art and stuff, that's the juice of it all. Yeah.
Mm-hmm. Well, I think you'd enjoy, like, Nausicaa in the Valley Wind makes me want to get into biotech stuff. Like, it's a very beautiful story. I think you'd just get a kick out of it. And it was mainly just making a joke. I think we're talking about some pretty heavy stuff today. And then the last question is, how can people help? What do you need help with that the listener can be galvanized to either be part of a study, maybe be a part of research, whatever you need?
I think if people have programming skill sets, right now we have this open source platform which helps people track, record, and measure their data and have it all in one place, which they own. And that's the open source platform. Now we need programmers to help develop standards, for data sharing. How do we create this? It's almost like Google Docs sharing. It's really not that different. Like, how do you give people access to your information? How do you limit, access, permission, that sort of thing? And so we have a little traffic here. Apologize. But,
no worries. We're going long, so I appreciate it.
Please edit some of my more vociferous types of comments for, like, just include them enough to be spicy and not enough to make me sound like a raving, cynic.
Yeah, I'll do my best. I typically don't do that much editing. I like people just to get like the natural sense of people.
Yeah,
Man, I'm dying today.
that's okay. We'll let you go pretty soon there, or we'll let
Yeah,
you go
yeah.
right.
So you need programmers. What type of programming do you need?
We're looking at Python programming
Oh,
and
Python's fun.
Python programming and bioinformatics with a medical uh, spin. So people who are looking at medical health data, biochemical data, bioinformatics with the outcomes. With a health orientation, not so much independent individual diseases, but what is overall health? How is it defined? What is the data that's necessary? Biological age scores. What are the top biomarkers that we need? But also just being able to share the data, creating a community. Also, we want to create a self-directed research community so individuals can create these ad hoc communities, groups amongst themselves, so they can share their data between each other, and they can. But we've got a lot of it. A lot of the pieces are already built, and so we need the reference ranges. A lot of this stuff is individually available in different databases, and those ones are constantly being updated. How do you bring all of these dimensions of data into a single context that's queryable?
Yeah.
And that is the hardest part. And so a lot of it is just grunt work, getting out there, finding out who's got the best resources for, say, metabolite reference ranges, proteomic reference ranges. It's a lot of work. And but once you have this resource in place, it becomes the ground truth, the source where everybody would go to. It would be sort of like it's a commons, it's a health commons, is what it is.
Mm-hmm.
And we need people to contribute to the health commons because it is the emergent value of the synergy of those different pieces that will give us the answers in the shortest period of time.
Thank you for joining us today with the Learn with Lowell show. Check us out at learnwithlowell.com. Anywhere podcasts can be found, subscribe. Tell me what you thought of this episode. Check us out on YouTube in particular. It's a new thing I'm doing. Timestamps and links are in the show notes. Thank you for coming, and I hope every one of you found something today that you're curious about to learn more about, and you'll go out and be curious and learn something new. Thank you, and have a great rest of your day.